Is now starting. All attendees are in listen-only mode.
Hi, Assalamualaikum and good afternoon. Welcome to Machinery and Equipment Productivity Nexus, in short MEPN, our third webinar series. I'm Mazlina, an EPN Program Manager from Malaysia Productivity Corporation. And EPN was set up as one of the 9 productivity nexus under the Malaysia Productivity Blueprint introduced in 2017. The main purpose of the productivity nexus is to drive the implementation of the initiative in close partnership with the governments. Machinery and Engineering Industries Federation, or in short also known as MEIF, has been tasked to champion MEPN on behalf of the machinery and equipment industry. The webinar is one of the MEPN initiative under our Talent and Manpower Development Work Group, collaborating with GMI on the niche topics, especially in the hydraulics. The title for today's webinar is Introductory Course to Hydraulic Maintenance Through Industry 4.0 Technology. Before we proceed, let me share a short introduction of our speaker biodata. T.S. Nur Afandi Sharif has a total 13 years, a hand-on experience in automation and mechatronic as a mechanical design engineer and also the engineering engineers both in industries and TVET. Currently, he is the senior lecturer in Malaysia Institute in an instrument automation and control section. He has also been involved in R&D for unmanned aerial vehicle for non-destructive tests, with Petronas Research for developing ultrasonic tests at high. He is certified trainers level 1 from Bosch Retro, Germany, back in 2014, and has conducted many hydraulic short-term courses for industry in Malaysia and abroad, such as ERL, PNMB, the Star Publication, Mega Steel, Petronas, and RR System Jeddah. While Encik IR TS Nur Azilan Jaafar is a committee member of METD, or namely as Mechanical Engineering Technical Division, Institute of Engineers, Malaysia. He has 20 years experience in tire manufacturing machine and CNC machine in design, maintenance, and retrofitting. Currently, he is the program coordinator for Machine Tools Maintenance Program in German-Malaysian Institute. He holds Bachelor Engineering in Mechanical Engineering from USM and Master in Engineering in Manufacturing System from UKM. So without further ado, I would like to appoint T.S. Nur Afandi to deliver his paper. Please welcome.
Thank you, Dr. Mazlina. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil mursalin wa ala alihi washabihi ajmain. Assalamualaikum and good afternoon. Guten Tag. First of all, welcome all participants to the webinar Introductory to Hydraulic Maintenance through IR 4.0. So, like Dr. Mazlina said before, we have 2 speakers today to cover the title. The first speaker will be me, and the other speaker will be Program Coordinator of Machine Tools Maintenance, also from German-Malaysian Institute. The lesson cover from the webinar are the number 1, principle of hydraulic technology. We talk about the principle of hydraulics, the theory and equation governed in the hydraulic principle. Okay, we have to cover this because I believe that some of the participants in the webinar doesn't have a little knowledge on the mechanic and dynamic of the hydraulic system. and for others that who are familiar with the hydraulic system, just consider it as a refreshment. Number 2, I will go through on the introductory on and on-off technology, also known as electro-hydraulics among my students. Then an overview about the optional hydraulics. Lastly, I will discuss briefly on the integration of the IR4 technology in hydraulic maintenance. Even though the time is very limited, I'll try my best to provide participants with useful information that hopefully participants can relate the hydraulic technology with the evolving technology in IR4. Okay. So, okay, a bit of German-Malaysian Institute. So established in 1991. So it's been around almost 30 years. So the main business of the German-Malaysian Institute is to provide the technical, vocational education and training for the students in the diploma, degrees, and GDVT student, German dual vocational training. So we also have the STC, and this is the technology center. We have the Precision Machine Technology Center, Collaboration Center, Distribution Control Center Technology by Siemens, and Hydraulic Technology Centers. So for the Hydraulic Technology Center, we have a certified training center by Rastroff. Okay, this is the some of the participants, which is the PNB and the PNB. So without further ado, we jump to the hydraulic slide. So introduction. So where can we find the hydraulic system? Okay, first you can see the hydraulic system in the aircraft. So this is establishment of the hydraulic circuit, electric and mechanical circuits in the aircraft. This is a Lockheed Martin F-35 fighter. Okay. So this is a Harrier jump jet. So we can see here, this one is a cockpit of the hydraulic of the Harrier jump jet. So this is landing gear. So the landing gear hydraulic operation is around 3000 psi. So this one is the isometric view on interpolation of the hydraulic layouts over here. We have this storyboard kilivons, and for the extruder, we have two hydraulic valve. Okay, we also can see the hydraulics in the automotive. Okay, this one is in the F1 car. Okay, this is from Brembo. Okay, you can see in the F1 car, we have the hydraulic by wire system. So this one is the pedal. You can see that when the force exert, then this is the master cylinders, the reservoir is on the left, and we go to simulator and direct go to the ERS, which is the energy recovery system, and we'll be triggering a signal to the accumulator and will be trigger the caliper. So for the production car, okay, this is the typical hydraulic system. From the pedal, we have the passive absorber, we have the field, then this one is pedal sensor. So if we compare using comparator and when relay the signal to the brake control unit, and directly go to the caliper. Okay, inside here we have this dedicated hydraulic system, which include the pump and this actuator, which is the brake caliper. Okay. Okay, this is hydraulic in one turbine operation. So this one is using the functional hydraulics. Okay, we can see here is the blade of the wind turbine. So the wind turbine blade angle is compensated with this wind speed. So the dedicated wind speed, so the dedicated turbine speed is depends on this angle. then the angle is controlled by these units. This is the cylinders. Sorry. So when it detects a presence of the high speed, then the cylinder will reactivate this plate to the desired angle and maintain the speed of the wind turbine. Sorry. Okay, this is the hydraulic assembly line. Yeah, production line. Okay. This integrate the articulated robot. We have the pneumatics, hydraulics system. Okay, so it have maybe 1,000 of valve, 1,000 of system. Then just imagine what happened when a single valve is problem and the whole one will stop. Okay, so that's a sample of application of hydraulics in the technology that we can search today. So a bit of principle. So hydraulics consists of two elements, which is the hydro and then the outlet. So the hydro is actually water. It's a fluid inside the hydraulic system. Then we have the outlets, meaning the pipe and the hoses. So this is the comparison of the hydraulic agricultural media. We have the electric, the hydraulic and pneumatics. I just pick 1 or 2 points here. Okay, the first one is the leakage. For the electricity is not comparable with the hydraulics and pneumatics. Then for the hydraulics, we have contamination due to the leakage, the cloggedness of the filter, so on and so forth. But in terms of pneumatics, we doesn't have any disadvantage apart from the energy loss. So for the second point, this is the energy storage. For electricity, then it's quite difficult, only in small quantities using batteries. Then for hydraulic, it's quite limited, okay, because it uses gases, okay, dipakai nitrogen gas. So untuk pneumatics, it uses a reservoir. The reservoir can be up to 3 or 4,000 meter cube, agak besar. Okay, then we go to the concept of accumulator. What is the energy storage in hydraulic actually? So I have a very short video on the accumulator. It is by Parker. Okay, we can see here, this is the chamber. So inside the chamber, we have the balloon type bladder. So inside the bladder, we have the nitrogen with initial pressure of 2 or 3 bars. Okay, let's say when we push and we give permission to the oil to enter this pop-up valve, then it will be compress this bladder. So the bladder will act as the counterbalance, and they have this potential energy. So the potential energy inside the bladder will ensure the chamber is in the designated pressure. Katakanlah kita nak 50 bar, then it will stay 50 bar until the signal the valve to be open. Okay, kita pergi kepada what is the difference between pneumatics and hydraulic. What is hydraulic actually? So pneumatics in terms of, okay, pneumatic can be compact, can be pressurized. So it very depends on the heat, okay, and the atmospheric temperature of the machine. Okay, so in hydraulics is uncompressible. So hydraulics can exert more power. It's very powerful. Then it is precise compared than pneumatics. Okay, of course, pneumatic is free, the air is free, but in hydraulics we must have a certain understanding on the fluid characteristic that we want to put in the system. Okay. Infinity as Azilan will be discussed on it. Okay, proceed. So hydraulic system. This is the basic definition of the hydraulic system layout. So in the input, we have the electric motor, internal combustion engine or manual drive. So this one is maybe in 50 and 60s. So for now, all using electric motor. So it depends whether we want to use the single phase capacitor run motor or we want to use the three phase synchronous motor. So this input providing the mechanical energy. So we have here in the center is a hydraulic system. So energy conversion is converted from the input in mechanical energy to hydraulic energy. So in control system, we have the open loop and closed system. So depends on the system of the hydraulics. And then it will couple back with the actuators and the system, maybe bending, maybe sliding, maybe compacting, banking, so on and so forth. So this one is actually to simulate a valve in the center, and this one is a pump. So we have various of pump, we have a vane pump, screw pump, radial piston pump, so on and so forth. So it will be covered on by the second speaker. So the hydraulic application. So this is the typical hydraulic application in the stamping. So in the stamping operation, we have the cutting process, we have the blanking process, and we have the forming, the trimming, so on and so forth. So this stamping process, I think during my day as an engineer, I think the biggest one, I think is 1,500 in ton. Okay, this machine using a clutch and brake system with integrated hydraulics in it. So we have two types of application of hydraulics. First one is stationary and mobile hydraulics. So we can see the stationary in the metallurgy industry, in car manufacturing, in forming, and small medium stamping machine. This one is around 400 to 500 ton of pressing force, and this one is the hydraulic motors. And this one is a dam in Netherlands, and this one is a T gorgeous dam in China. So in mobile hydraulics, we have the DMAC cats. Okay, so this one is a typical forklift, and we can see here, and you can see this lift in the workshop. So sorry, the pace is quite intensive. Okay, so we go to the principle of hydromechanics. So in hydromechanics, we have two type of element. The first one is hydrostatic and hydrodynamic. So in units, we have Pascal, bar, megapascal, PSI, okay, millimeter hydronium or millimeter mercury, millimeter H2O, so on and so forth. Okay, so this is the conversion of these units. Then Pascal law said that the principle of restating external static pressure exerted on the confined fluid distribute evenly throughout the fluid. So kalau kita ada satu tempat yang tertutup dan kita exertkan force dekat padanya, then we can see that the pressure will be in all direction and the same in all direction. So this is power transmission application using the hydromechanics and hydrostatic. We know that according to Pascal law, P1 is equal to P2. So we can say that F1 over A1 is equal to F2 over A2. Okay, we bypass this. So this is a displacement transmission. We know that V is a volume. V1 with this displacement S1 is the same of the V2 with this displacement S2. So V1 is equal to V2. V can be in liter, meter cube, cc cubic centimeter, and others. So this is displacement transmission. Okay, I pass this one. So about the characteristic of the hydraulic fluid, we have 4 characteristics. The first one must be able to transmit energy, to lubricate, to provide a seal between moving part, and to transfer heat. So 2 types of hydraulic oil. We have the mineral-based oil dan satu lagi kita ada phosphate ester-based oil. Okay, the different these two ialah pertama sekali yang first ni ialah low flash point, which mean it's easy to get burn, mudah terbakar, dan ni agak susah terbakar. So hydraulic oil phosphate ester ni agak mudah terbakar, yang nombor satu ni agak kurang mudah terbakar. So characteristic of the fluid in hydraulic, the first one is viscosity, kelembapan, flow, cavitation, and flow rate. So viscosity is resistant to the flow. Okay, we can see here the viscosity STR is less than the viscosity of fluid C. Okay, flow is pointing whether the fluid is a laminar or turbulent, because in turbulent fluid flow it will increase the pressure drop. Okay, so cavitation. So cavitation is governed by the Bernoulli theorem. We know that Q1 is equal to Q2 in the closed pipe. Then you can see here, if this has a small orifice, then it will develop a low pressure region and develop a bubble, and we pop around here, then will be cause metal erosion. So this is the effect of the cavitation. Flow rate also governed by the hydrodynamic, which is the Bernoulli theorem. So Q1 equal to Q2, and V is inversely proportional to P. So we just pass this hydraulics characteristic. So we straight goes to the pure hydraulics. So this one is the 4-3 hand lever with bypass in the center. So this one is a typical arrangement in the hydraulic circuit. And this one is the one way flow valve with pressure dependent. Okay, this is round valve. Okay, you can see here in the middle is the spool. So we have the armature coil in A and in B. So if we trigger this one by 24 volt, then the spool will be moved to the left and the spool will move to the right. So this is the cross section of the spool and the cylinder over here. Okay, so this is the hydraulic circuit. You can see here this one from left to right. This is the typical DIN circuit. So we have a 24 and 0 volt. This one can easily be done in the FluidSim software. Okay, so we'll get on to the proportional hydraulic. So this one is the valve with the onboard electronic. So we can say that the proportional valve is like a stable motor. It can set the ramp, so the running time and the acceleration compared to the depends on the command value. So the command value for the hydraulic proportional hydraulic is positive 10 volt and negative 10 volt. Okay, so this is the command value layout. And this one is the one of my participants in Petronas self-response. Okay, I just give them a question and they design themselves and try to assemble in this workbench. So this one is the proportional hydraulic practical. I asked them to integrate with the on-off valve. This student try to explain to their friends on the integration and the effect of the command value here on the RPM the speed of these cylinders. Here is a simulation using the fixing. So I drill them to run around 20 rounds and I design with the 4 cylinders. Okay, it goes to the industrial 4.0 map. Okay, first mechanical loom in 1784. Okay, the first industrial revolution introduced by the introductory of the steam engine. Okay, by the end of 18th century. Then we go to the industrial revolution 2, when the introduction of electricity. This one is the Union Stack Yard in 1870. Then on the third industrial revolution, we have the PLC integrated with this the production line in Moricon 1996, 1969. Then we are in the midst of the industrial revolution 4.0. Okay. So actually, industrial revolution 4.0 have 9 pillars. Okay, augmented reality AR, system integration, until simulation. So maybe I just pinpoint 1 or 2 pillars in IR 4.0. Okay. So the first one is a big data analytic platform. Okay, I try to small my scope to using Hadoop HDFS. So this one is data source. Let's say you have the vibration issues on the motor and the pump. So you put the piezoelectric sensors. Okay, then we can have the flow rate pump. We can have the pressure sensors. We can have the counting sensors which count the digital signal on and off, so on and so forth. So in data ingestion, we use the Scoop, Kafka, and then it will store in the Hadoop.hdfs file. So it can be processed using the Python. So it's a Python. You can use maybe Matplotlib to map a graph, so on and so forth. Then we can eventually go to the Power BI or Giant to visualize the data. So the data also can be stored in the data warehouse. Okay. So this is the challenge of data engineers in perspective of the big data analytics. So we have a 5B. So maybe I just discuss on the velocity. So velocity is actually the data now. It's actually the noise inside the data. Let's say you have this piezoelectric sensors to monitor your vibration of your pump and the motor. Then you have many types of noise, right? So you can integrate maybe using the Fourier fast transform to indicate, to analyze the spike on the frequency on the time domain. Also, you can use the wavelet transformation to segregate the type of the signal that you want to segregate. So this is a data dashboard. This one using, maybe you can use using Power BI, and maybe you can use the Giant Fusion. Okay, we go to the next pillar, which is the Internet of Things. The aim of the IoTs is to enable the interconnection and integration of the physical world and the cyberspace. So it has 3 domains. The first domain is the user interface. You can use the tablet, smartwatch, and etc. For the network domain, you can use the IoT gateways. So in the market, we have multiple type of IoT gateways and brand. So you can have from the German IoT 2040, Rexroth, Parker, Schneider, and so on and so forth. So in the network domain, you also have the RFID tag, the camera video. Maybe you can integrate it with the OpenCV image processing. And for the sensing domain, okay, you have a multiple type of sensor that can be used in the application of the hydraulics. So we go to the IoT system out. So we can have multiple type of multiple controller over here. So we have the workstation 1 to workstation 9, and goes to the IoT 2040. This one is a Zeman. Then it goes to the cloud. Then the workstation here, WSTTO can monitor and supervise all the data inside the cloud. So this is a single IoT layout. Okay, this one is the PC, then it communicates by Ethernet to PLCs and to IoT gateway and directly to cloud. Okay. So this is a typical articulated robot. I think this one is the ABB, maybe KUKA. So just imagine we have this kind of valve integrated with the robot. Let's say this one is 220 valve. Let's say you have 200 of this articulated robot in your factory, and you have the child factory. So using IoTs and using the big data analytics, I think it will increase your productivity. And with the data real-time monitoring, it will increase the transparency in your productivity. So, okay, this is what can be monitor. Maybe this one is the cavitation issues that cause any erosion to the valve. Okay, this is a metal pitting. Okay, the last pillar that I want to discuss is augmented reality, AR. So AR is an interactive experience in a real world environment. The goal of the project in real world environment are to enhance by generated perpetual info. So you can see here, using this tablet, which you pinpoint at the marker inside your working envelope, then it will be pop up this kind of information of the motors and this one. And if you goes to the point over here, like just like HP, then it goes the information that you need to know about the pump. So I have one video. This one is from Schneider. Okay, just read it first. Okay. Okay, let's say this is a problem on the pressure chamber. Okay. The technical guy may be across the continent. Then when it pinpoint, we detect the marker. Then, okay, the technical guy will guide the technician in real time. Okay. Okay, how much the pressure must be adjusted. So is it the valve? Okay, or not, how to open the valve in real time. So one more example is this is the pump. So using augmented reality, okay, when it detects the marker, it can show the technician how to open the pump. This one is the clock filter, how to order, so on and so forth, interactively. Okay. I think it's very practical for the machines maintenance. Maybe a new guy want to step up in the field, and I think AR will help them a lot. So that's all for me. Thank you for watching. So hopefully you can have a knowledge that maybe we can use in your production line. Maybe you can share with your colleagues and so on and so forth. Thank you very much. Without further ado, I will pass my presentation to Infinity S. Noriza Jaafar.
Tengok from sorry again. Oh. Sorry, there's some technical here. I'm sorry. Technical problem.
Okay, while we are waiting,
Okay.
maybe
Okay. It's now ready.
IR, while we are waiting,
Yeah.
there is some question posted by the attendees, Encik Ahmad here. So they said that is there any AI presentation ever in GMI? Does this AI in GMI? Could anyone of you can answer this question?
I think Afandi can answer that.
So currently we doesn't apply AR in GMI, but we have planned short course for the mechatronics lectures in AR, and we try to collaborate with our partners, means our colleagues in others section, which is electronic and network section. So maybe after the MCO, we'll go on it.
Okay. Okay. Can I start? Okay. Thank you, Mr. Afandi. So sorry, just now there's some technical on my PC, so I will take about 30 minutes at least to present on the Industry 4.0 solution for hydraulic maintenance. So welcome to maintenance hydraulic in Industry 4.0 solution. So I will introduce many aspects of troubleshooting and maintenance, but not too detailed or too technical based on my experience. And I will share the information how the sensors and Internet of Things that can help you to understand the operation of your hydraulic equipment in your factory. To adopt the IoT and data generation in hydraulic maintenance, we should understand first the conventional method, how we repair the hydraulic part component before. When you face a problem such as a hydraulic pressure drop, pressure fluctuating, or low pump flow, leakages, a system produce bad smell, maybe system produce noise or system not running. So I recommend to start troubleshooting on hydraulic system by doing all the inspection as below.
Excuse
Hydraulic
me,
oil,
RR, can you share
yeah.
your webcam? Because we can't see your presentation right now. So perhaps you can go to your webcam and share your presentation.
Okay,
Still can't see your slide.
I cannot see.
Okay, now we can. So you can
Yeah.
enlarge through the PowerPoint slides. Okay, thank you very much.
Okay. Sorry. So can I restart again or continue? Okay, I just continue to adopt the IoT and data generation in hydraulic maintenance. We should understand first the conventional method, how we repair the hydraulic parts component before. When you face a problem like hydraulic pressure drop, pressure fluctuating, or low pump flow, leakages, system produce bad smell, maybe system produce noise, system not running. I recommend to start the troubleshooting on the hydraulic system by doing all the inspection as below. For hydraulic oil level, so sometimes you have a problem to see the level because either there is no level gauge at the reservoir or it has but not sure in what level. Sensors such as float level, float water level, and ultrasonic sensor can be used. So hydraulic temperature, as I prefer you to look at the heat exchanger, oil chiller. So this is how the temperature sensor play its role. Yeah. Hydraulic oil type. This is sometimes people don't care what type of or brand they use, but every oil company, they have their own advantage product on their performance wise. The most important to choose the correct type viscosity for the machine, referring to machine maker requirement or recommendation. So as you know, the hydraulic oil also have their own grade and it can be mineral or synthetic based. Of course, there is an electronic refractometer now in the market to measure the quality of this hydraulic oil. So let me explain more detail on every part of the hydraulic system. So when we talk about reservoir, sometimes the machine maker make a tank reservoir designed incorrect with no buffers and diffuser plate. So when the oil level too low due to leakages, so one drop of oil that drip once per second will lose about 1,500 liters a year. Depend how bad the leakages. When it too low, the return oil just causing the vortex in the reservoir and including air into the pump. So fluctuating pressure or slow flow may happen and it will cause the whole machine vibrating, noise, low pressure, and may cause machine breakdown. Other than that, most hydraulic systems come with breather. It is also an inlet refilling oil cap. This part is very important. When it was too dirty or blockage, the pressure inside the reservoir cannot balance the atmospheric pressure. This will make the pump difficult to work. So hydraulic oil without inspection for a long time may cause the inlet strainer then stuck blocked by slush and make the pump fail to work. So level sensor can be used as a method to solve the oil level indicator. So the sensor, either float type or ultrasonic type, can be fit into the reservoir, and the IoT device such as PLC IoT or microcontroller like Arduino with Wi-Fi generated can be transferring data to MQTT and to broker cloud system. So for the temperature monitoring, you may also connect it to RTD. Is a industrial temperature sensor like PT100 that can then be connected to analog to digital converter and to protocol converter and to IoT module. So look at the upper left corner. There are two example different level sensor that easily to find in the market. And beside the level sensor is an example of RTD PT100 sensor. All the real-time data will display on your PC or smartphone through the dashboard. Yeah. So when a hydraulic system fail, you will also look into hydraulic oil filter. So the condition, how it was used, when was the last you changed, and you also will look into hydraulic pump, where you have to check any blockage, wear and tear parts, leakages, motor coupling condition, or the AC motor. You will also face the hydraulic actuator and seal problem. So piston not move, maybe due to damaged leak seal. Sometimes the shaft was broken or damaged or bent or dented, and this can cause the seal damage. I believe the linear position sensor with combination with pressure sensor can use to determine any seal damage. So this is the filter casing with a sensor indicator, and the hand toggle there is to stop the flow so that you can change the filter element. Above here is a magnetic switch sensor, and it will connected to IoT gateway. So temperature sensor, pressure sensor, current sensor, flow sensor, even protection circuit like MCB from the pump also currently now have capability to transfer the analog signal to the digital signal for IoT and cloud. This is the idea how the problem hydraulic actuators such as leaking seal can be detected by combining two different sensors such as a linear position sensor and pressure sensor. The lower left corner photo show the example of linear position sensor that easily can find in the market. So attached to the outer cylinder and the pressure sensor attached at both inlet outlet actuator to detect any abnormal pressure present. So often an electrical issue will be also affect the hydraulic operation. So don't get focused on hydraulic problem until you have also review some electrical issues such as on the electrical control. Sometimes they no or low voltage supply, or maybe the switch power supply malfunction, or maybe the transformer burn, or maybe incoming no power supply. So you are also to check the proportional valve, or sorry, not valve. Sometimes the valve have on board electrical control, like what Mr. Afandi just explained, with either a current or voltage common missing. Sometimes the relay that power on the valve not working, or maybe the coil at the proportional valve is damaged. Some proportional valve have the LED indicator, but some not. So you may face a little bit strange when the LED is turned on, but the hydraulic still not working. So this is a minor case. The coil was defected even though the LED is turned on. So this time the electrical knowledge is very important. You have to find the source of electrical problem in the diagram. As you know, sometimes the reservoir of the system was equipped with such sensors such as temperature and pressure sensor. This sensor work as interlock system. It may defected in certain time or period. When the sensor is not working, the system will stop. Troubleshooting electrical in electrical panel to circuit diagram sometimes make difficult. So in modern technology right now, you may not go to troubleshooting on electrical panel and troubleshoot using electrical drawing anymore. So thanks to PLC with IoT gateway that help you to display the error on your PC and smartphone. The PLC with IoT ready in market now. Just plug in all the digital signal from the contactor relays, MCB to PLC IoT such as Siemens IoT. So although you can fit the sensors to monitor the hydraulic oil condition, you should also have to go to shop floor and do hands-on. So many machines such as a stamping machine, CNC machine, press machine, or any machine that moving using hydraulic oil, the heat transfer from the friction between the two metal base, heating from the process or heating from the heat generated by the heavy press actuator that will generate the heat and flow into the system. So any hydraulic system that very hot, above 130 degrees Celsius, or little bit warmer, maybe below 130 degrees Celsius, may cause a few problems on the machine and system. So the best solution to any machine using hydraulic but without cooling system, you can buy separate oil chiller. It's a refrigerant type and absorb all the heat from the heat exchanger, where the two medium, hydraulic oil and refrigerant gas, was in separate line, and it play the role of heat transfer. So you may connect the chiller to the oil pipeline. So the best position, pipe return to hydraulic pack. Yeah, mostly the best temperature for hydraulic is the room temperature between 30 to 40 degrees C. So some cooling system using heat exchanger and some using the cooling fan. I think it was enough, and sometimes it was equipped into the system. So please be reminded that the hydraulic oil is very high temperature, will start breaking down, causing the sludge and varnish in the system. This photo show hydraulic oil chiller in CNC machine in GMI. So both is using refrigerant cooling system. It helps to prevent the CNC spindle bearing that have the oil circulation from overheat and make the bearing lifespan longer. But the chiller also need to be serviced and maintained. Some like our air conditioning unit. The condenser fan, the dry filter, the expansion valve, compressor also need to be checked, cleaned and serviced. So the gas capacity is also need to check regularly. So exactly you can take the temperature, pressure sensor signal from the existing control to connect to IoT module and to monitor to the whole chiller performance. So beside physical sensors and hydraulic component, selecting the wrong oil can cause system fail. So this table show the ISO grade for hydraulic oil. Any brands or company who produce this hydraulic oil will label this code on the bottle. So it show the kinetic viscosity table in 40 degrees Celsius, either mineral or synthetic base oil. The supposed show in result with average viscosity as table listed when tested in the lab. For example, ISO VG32 plus. Why the VG32? So look at the table, the maximum viscosity in 40 degrees Celsius for this type of hydraulic oil is 35.2 and minimum is 28.8. So in average viscosity is 32. So many machine manufacturers use ISO VG32, 46, and 68 for its hydraulic system, and commonly easy to find in the market. So in addition, filter type and material also important. This slide show a few type of filters. Hydraulic filter to protect system components such as a valve and hydraulic actuator, motor from blockage, and to reduce oil contamination. So you should record when the last you had changed the filter, and I believe the routine replacement has been set in the maintenance schedule. So when we are going to change the filters, we have to make sure the correct filter from machine manual, especially the size. Other than that, some characteristic of the filter such as beta rating, type of filter media, and filtration efficiency. So the filter are made by a different material such as fiberglass, mesh, microglass, paper filter, stainless steel, and cellulose type. So all type have their own performance and quality, filtration efficiency to protect inlet strainer so from blockage. So with know-how in hydraulic filter, you can keep your system contamination free. Okay, this slide show a few types of hydraulic pump. Sometimes it's difficult to recognize from outside appearance what type of the pump. It can be traced from the label at the pump or at the machine manual. Generally, the pump is not easy to damage, but traditionally every annual or when you suspect a pump problem, you have to dismantle the pump and see all the tiny components inside pump. If you are lucky, you can see the damaged parts or wear and tear part. But be careful not to missing any small or tiny parts during assembly work. So the most common hydraulic pump in the market is gear, axial, vane, and sprocket pump. So for example, the vane type, it has a tiny hard fiber or steel that easily to damage. So sometimes the cotton rag was accidentally dropped inside the tank and entering the pump and make the pump damage, malfunction. So okay, the upper right photo here show axial pump dismantled by DMI student during the pump maintenance practical. So however, hydraulic pump nowadays have a solution in IoT technology. So this is the example of IoT and hydraulic pump. Case drain can be key indicator of pump health by monitoring flow, temperature, and pressure. So user can enter information such as case drain port size, maximum case drain pressure, continuous input shaft speed, maximum displacement, and so on. So then user can monitor future on current and historical data of pump case drain temperature, pressure, and flow. So also can monitor the real-time alert notification to phone or email. And user can also monitor the individual pump efficiency report or can monitor the historical pump data and can make the scheduling of a predictive maintenance for the efficient pump. This one is one of the GMI hydraulic pack maintenance teaching kit. It has two unique different type of pump, axial and rotary vane pump. So student may allow to dismantle the whole system and to see the internal structure of the component of the hydraulic pack. So even though the system was equipped a lot of sensors to prevent the system to sudden fail without notification, but the selection of hydraulic actuator seal type and material also important. So the seal can be easily damaged due to overheat temperature, oil contamination, wear and tear, and shaft dented. So hydraulic actuator have a different type of seal shape the correct type of material will lasting the performance of the actuator. The photo show one of the model of actuator with different type of seal shapes such as piston seal, rod seal, and wiper seal. When you select the seal, please consider the material type. The more expensive price, the more life lasting. So some materials such as silicone seal, vitamin seal, nitrile seal, and synthetic rubber seal can be found easily in the market. So you may refer machine manual for any recommendation of seal type and material. So besides the pressure drop inside the hydraulic system also can be cause of pressure relief valve, PRV. So PRV, pressure relief valve, are used in hydraulic system to limit the system pressure to a specific set level. So for some period, a year use, it may less perform or too old to work properly. So 70 to 80% of pressure relief valve problem is leak, chattering, or rapid opening and closing. Sometimes failure to open at designated set pressure and long blowdown. So closing too far below set pressure. So accidentally too high pressure can cause damage to the system. So always recheck the pressure setting on the PRV. So okay everyone, let's move to another slide. So I will share some information on the preventive maintenance interval for hydraulic system. So basically the preventive maintenance interval can be found from machine manuals and recommended by the machine maker. So, but most preventive maintenance involve the common checklists such as oil level, filter condition, leak on fittings, pumps, and motor coupling, breather accumulator PRV, seal, and gasket. Here, I also want to share the daily maintenance checklist that you can also follow. The first, you can check the oil level, as I mentioned before. Then check the oil temperature, check oil contamination, check any leaks, check and tighten loose screw on valve, PRV, pipe fittings, motor pump or coupling. Then verify the pressure gauge reading. Check, monitor running noise from pump, and clean the surface pipe, pump, valve, or outside the tank. For 6-week interval maintenance checklist, you can also check and replace the oil filter, clean the strainer, or internal strainer may easily remove without draining the reservoir oil by pull up the pump. Commonly, the strainer was fit together with the pipe to the pump. Other than that, you may replace the old fittings or hoses that continue leak. You may also check and replace leaking seal. You can check or replace new actuator seal. So in 6-month maintenance interval checklist, you can take the oil sampling, especially for those who have large hydraulic system with large reservoir, so large volume of hydraulic oil. Company have to invest high cost to buy new hydraulic oil. So oil sampling is important to know the oil quality condition to predict when the oil should be replaced. In 6 months, maintenance also the current time to check the pressure vessel and accumulator. It also recommend to check the AC motor condition, maybe the coil resistance and motor coupling condition. So the most important part of this time to check the PRV or pressure relief valve that mentioned before. And the final part is to check the breather to prevent the airborne contamination and moisture entering the tank. So for annual interval maintenance checklist, the best time to change the new oil. It is also the best time to dismantle the pump and to clean and service. So it is also recommend to dismantle the professional valve and AC motor. When you have planned to change the new hydraulic oil, it is also the best time to clean the reservoir and also to clean the buffer or diffuser plates and the internal strainer from clog. So many companies prefer to use Microsoft or Excel, Microsoft Word to list all the preventive maintenance interval, but all the maintenance interval that I will suggest before can be set and generated into the system called CMMS or Computer Maintenance Management System. The software can be found many in the market, even in the internet. By using the CMMS, the maintenance duration, maintenance performance, maintenance checklist, maintenance SOP, maintenance notification, then can easily monitor and can easily watch from your PC and smartphone. So, okay, this slide shows you the recommendation action to predict the hydraulic system problem. So, predict maintenance technique can reduce unplanned downtime and increase productivity. Predictive maintenance can be accomplished via remote monitoring to allow user to maximize equipment efficiency in the hydraulic system. So to predict the MTBF of the system, so I suggest that the system should fit with a sensors. So the analog signal, the current, then should be recorded daily by the paperless recorder or to IoT. So some sensors listed above can read a few characteristics of the system. For example, the pressure. So the pressure sensor can be fit at the pipe after the pump and returning pipe. So the flow, the electromagnetic flow sensor can be fit to the pipeline. So the temperature or sensor can also be fit to all components in the hydraulic system. And the vibration, you can fit the vibration sensor to the motor or pump. So other than a physical sensor, to see the abnormalities of the system, the oil quality also can predict the emission condition. So the best solution by making an oil sampling from the point downstream of the system. The oil analysis will present amount of wear, debris, or other contamination in the oil. So portraying the oil in the system is as clean and eventually resulting in unexpected downtime. So nowadays, the predictive maintenance can be integrated to CMMS. So whether you need to track hydraulic system through oil viscosity, temperature, or vibration, the tool within CMMS system can help develop accurate prediction when a hydraulic system will require maintenance replacement. Yeah. This shows some example, the signal output from sensors that recorded and show in historical data. So any abnormalities can be predicted when the data show any abnormal condition from the digital data recorder. So other than separate sensor fit to the system, diagnostic tools can be as simple as plug and play digital pressure temperature recorder that measure pressure spikes or drop experienced during the shift or over an extended period of time. So they can be as complex as tools that measure a variety of key hydraulic system data points simultaneously, including pressure, temperature, and flow. So the lower right photo show the data of oil sampling from the lab report. But with the latest technology, the device IoT such as continuous oil conditioning monitoring was introduced in the market. So this is the sensor that you can find in the market that installed directly into the hydraulic pipeline for continuously monitoring the quality of hydraulic oil. in addition to offering significant advantages to plant equipment maintenance. So the following plots provide a graphical representation of water contamination and oxidation measurement by the sensor. Okay, so I think we are now at the end of the slide. After this presentation, I believe that daily routine maintenance on hydraulic system is still important to prevent breakdown and lack of production. Yes, but latest technology in sensors with IoT will help a lot to operator to solve hydraulic problem and maintain interval. Of course, cost and time savings is important, right? So I'm sorry that in this webinar, so I cannot cover all the detail on how the Industry 4.0, especially the IoT, especially the sensor configuration. So, but I hope that my presentation will be enough to cover a basic about IR 4.0 solution for hydraulic maintenance. So, thank you.
So thank you, Excellency Asnozil Jaafar. So we have a couple of questions over here. Okay. Okay, this is from Mr. Jin Cheng Ao. So does the hydraulic system apply in aerospace sector, such as aeroplane and space station? So, Azilan, you want to answer?
Mr. Ben, you can answer that.
Okay, if we see the Challenger in Discovery in the space shuttle of the United States of America, they use like they use a space aeroplane each type. So I think to answer your question, it have some extent to it. So if you see the tragedy in early 1990s, so the Boeing 737, so it have a rudder problem. So the rudder problem is caused by the frozen fluid, so frozen fluid on the hydraulic system. So to answer your question, so the Challenger in Discovery is already done it, but if you go maybe beyond Mars or beyond Jupiter, maybe the point, the dew point for the attack Mercury is so intense, or maybe around negative 1,000 degrees. So it depends on the ability of the fluid in the hydraulic system to withstand this kind of harsh environment. So did that answer your question? So we have a second question from Mr. Ahmad Hairi Hamzah. What is the difference between IoT and SCADA? Is near? Azilan?
I pass to you to answer that.
Okay. I think in answering your question, I will look on 2 points. The first one is the data communication, and the other one is the data presentation. So most of the SCADA, okay, now is using the cable or wired connection. So if looks in IoT, so IoT nowadays have their own Wi-Fi capability. Let's say you have the smart sensors for the cloggedness of the oil inside your filter. Then the data is very robust that can be connect to the IoT gateway. Let's say you want to connect with the Raspberry Pi or the Nano, and it will go direct. It will direct goes to the DBMS or the cloud. Then you can make it interactive. So by make a chart, or maybe you want to differentiate between the actual performance of the graph in the flow versus pressure chart, so on and like that. So I think the other one is the data presentation. So in data presentation, usually the SCADA using the HMI, which is the human machine interface. So for the IoTs, it can go to the DBMS and you can play around. You can make your own data visualization. Maybe you want using Tableau or Power BI. It depends on you. You can trigger it, and you can trigger other signal that maybe can integrate with the ERP or MRP, so on and so forth. To answer maybe your question, I think the SCADA is an element in IoT. So it will complement to each other in developing a very informative and robust information gateway to the customer. Okay, I think the okay.
There's another question there.
Other question. Okay, Shadi Ahmad, does this AR, I think, sorry, I have replied to the question. I think that's all the question here. Maybe I will pass to Dr. Mazlina. Thank you very much for your participation.
Okay, actually there is question from Mr. Yaakob and also Encik Ahmad Faizal. Maybe we can answer both of the question because we still got time. So question number one is, if our hydraulic system already end of warranty, what the best practice to doing maintenance and which critical part must be focused to maintain activity or study?
Okay, let me answer that. So when you have the hydraulic system, but it's already end of the warranty, I think the best you can follow all the maintenance interval in the manuals of manual books from the machine manual. Normally, it will take involved in some important part, especially on the filters, the hydraulic oil. So this is the item that you must always consider to replace, even though your operation is not operate for a long time. But the hydraulic oil is still considered to replace, and the oil filter still considered to replace according to the recommendation by the OEM. So the rest parts, especially the pumps, the pipeline fittings, I think should be no problem. So every technician can overlook all the system and try to tighten all the fittings from the hydraulic fittings. So make sure that there's no leaking, and to make sure the temperature of the hydraulic still in the room temperature. If the temperature is overheat, it will cause many problems to the machine, to the system also. Yeah.
Okay, so we have one question from Mr. Yap Tin Choi. I will unmute his speaker so he